Okay, now to write our own geometric proof for a congruent triangle. I've deliberately picked this example because it gives me great flexibility and shows you that you can often find more than one way to write a proof. Now, the key thing to do is to choose which of these you're going to use and then go for it, just explaining every step of the way how you knew that you either had three sides, or you had two sides and an included angle, or you had two angles and an included side, or the right angle, hypotenuse and side. I'm going to write this a few different ways to show you. Now, if I'm going for side, 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 and this one has flexibility, some won't, and you'll need to see which of these you need to go for. If I'm going for side, 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 I can see straight away that these two sides are equal. I'm trying to prove that these two triangles are congruent. They've got the same side there, which has been given to me. They also share BD, so that's two sides straight up without really trying too hard. So all I need to do is prove that AD is equal to AC. Now I could do that by explaining that BD, because it lands in a right angle here, and because this is an isosceles triangle, BD will actually bisect AC. So that shows me that these two are the same. So just list your things out one at a time. You can start with the tricky one or start with the easy one. Let's start with the easy one. AB equals BC. So you state it just as a fact. Then in brackets you write how you know. Well, how do I know they're the same? It was given to me. So that's nice and straightforward. All right, BD is in both of the triangles. So I just write BD is common. Okay, and I don't really need to write anything there. Now, how do I know that AD is equal to DC? Well, first write down that it is, and then in brackets explain how you know. So I would say ABC is isosceles, so BD bisects AC, since BDC, which is an angle, is 90 degrees. And how do I know it was 90 degrees? Well, that's given. Okay, so now I've got side, side, side. I've stated them all and I've given reasons in brackets. The last thing to do is to basically just restate the question. ABD is congruent to CBD. If you like, you can put the three dots at the front, which means therefore. It's a nice way of sort of finishing it off, like there you go. Now, after this, we need a reason. How do we know? Because side, side, side. It's got three equal sides. So every one of these geometric proofs basically needs a minimum of 4 lines, because you need to prove 3 things, 1, 2, 3, and then you always need to finish with that congruence statement explaining what the proof was. All right, so can I write this another way? Well, yes, I can. Let's start with the same 2 bits here. Shall we start with the same 2 bits? No, let's actually just start with this. We know that those are given. If I was going for side, angle, side, it's pretty easy to prove that this angle and this angle are the same. How do you know? Well, because this is an isosceles triangle and base angles are equal on isosceles triangles. So if I have this side and this side, then I can, and I've got the angle that's included, then I'm there. Okay, so what I'd need to do is start by saying these sides are the same, and then I'd need to go, all right, now the AD equals DC, and I'd give that same reason in brackets that I did before about the isosceles triangle and BD bisecting it. We've already written that down, so I'd put that. And then after that, I'd say angle BCD is equal to angle BAD. Now notice how I used the symmetry there just in the naming of the angles. Instead of calling this DCB, I called it BCD and BAD, because it's A and C that are in the same sort of corresponding place. Now how do I know they're the same? Because I just write they are base angles of an isosceles triangle. Obviously, you write that full thing out. I'm just being a little bit quick. Isosceles triangles are equal. Okay, so double check each time that we've got what you need. I've got a side, I've got another side, and I've got the angle that's between them. And I had a reason. Obviously, I'd write that in. So what did I find? Therefore, ABD is congruent to and you write the triangle. Triangle ABD is congruent to triangle CBD, and the reason I know side, angle, side, that was my proof that I've used. All right, what would we do if we were doing angle, angle, side with this? How do I know I can use it? Well, I've already shown that I can prove these angles are the same. Okay, how would I go about proving these angles are the same? Well, I'd actually just state, let's have a look at how to do this. I'd say, all right, angle BAD is equal to angle BCD. I should have probably left that there. I've rubbed out the reason now. We've already done that one. We know how to do it. Okay, how do I know that these two angles are the same? Well, let's just start by writing that they are. BDA is equal to BDC because ADC is a straight line. We can even call it an angle. ADC is a straight line, in brackets 180 degrees, and we already know BDC is 90 degrees, don't we? BDC equals 90 degrees. How do we know that? It was given to us. So we write given, just be really thorough. So we've got that angle, we've got that angle. Remember, if you've got two angles, you've basically got three. The other one can only be a certain thing. So if you didn't want to do this, you could actually explain that this being an isosceles triangle that meets this at right angles, it bisects those two. You could have gone for that. I just thought this was a little bit easier. So I've got two angles. All I need is a side in the same corresponding position. So at that point, I just say BA, let's call it AB, is equal to CB. How do I know? That's given. So now I have angle, angle, side. I go ahead and I say that my two triangles are congruent, and in brackets I put angle, angle, side. Now, I think from here you can see how I do right angle, hypotenuse, side. This is a right angle. How do I know? It was given. And this is also a right angle. How do I know? The reason's here. ADC is a straight line and BDC is 90, so 180 minus 90, that must also be 90. So that gives me the right angle. Hypotenuse, AB equals BC, given. We know how to write that. And then all we need is one other side. Okay, so we've got one side, we've got a right angle. You'd maybe just go for this side, just say BD is common, so they both share it. It's quick and easy to write. So the take-home points you need to learn here, 4 steps. 3 lines are to prove the 3 things that the two triangles have in common. You write down what's equal, you put in brackets the reason that you know it. If it's something obvious, you say it's been given to you. If it's something you've had to deduce, you explain the geometric proof, if you like, of how you know that. At the bottom, you state that the two triangles are congruent, and in brackets, you put your reason. And that's how you write a geometric proof for congruent triangles.